We are talking about classifying triangles, and we want to identify and classify triangles by angle measure, identify and classify triangles by side measure. And the first thing we want to talk about is what exactly is a triangle. So a triangle is a three-sided polygon formed by three coplanar segments joining three non-collinear points. So that means they all have to be on the same plane. All the vertices have to be on the same plane, but they can't be on the same line, because if they're on the same line, 3 points in a line, and then there's no triangle there. So let's talk about how we can name this. So basically we name it by the vertices, or the points on the corners, and we can name it anything we want. Any of those, we can start anywhere we want and name it. So we could call this triangle FHM. FHM. We could call it triangle, we could go the other way and call it FMH. Or we could start with a different point. We could call it triangle HFM. And we could come up with more names. As long as you name them in order, use a capital letter, and you put the triangle in front, then that's the proper way to name a triangle. Now we can look at the ways that we can call the sides that make up this triangle. We have line segment FM right here. We have line segment MH, and we have line segment HF. And again, we can name these sides in a different order if we want. That's fine. The vertices that make up this triangle are the three corners where the angles meet. So we have vertice F, vertice H, and vertice M. And then the last thing we have to talk about are the angles. And basically the angles are the vertices. So we could call this angle F, which would be this angle right here. That would be angle F. We have angle H, which would be this angle here with H as the vertice of the angle. And we could have angle M. Those are the three angles that make up triangle, this triangle here. So we also are talking about classifying triangles. So the first one that we're going to talk about is an equilateral triangle, and that has all sides are the same length and all angles are congruent. So in this case, we have the triangles here, and we can see that we have three congruent sides. Any side that is congruent on a triangle, that means the opposite angle is also congruent. So if this side right here, if we're going to mark this with 1 to match the side there, and this one has 1, and this one has 1, if all the sides are congruent, then that means all the angles are congruent as well. So we look at the next one here, we have 2 congruent marks in all of them. So just to check, I'll map and say, all right, that's got 2. Okay, the opposite angle, that has 2, and the opposite angle, that has 2. Now this one's a little bit different. So this one's marked without any congruent marks, which is fine. You can mark it without any, but I'm going to add 2 here. I'm going to add 2 here, and I'm going to add 2 here. So there's 2 marks here, so I'm going to put 2 here. There's 2 marks here, so the opposite side. 2 marks here, so the opposite side, and so we can see that the sides are also congruent. Next one that we have is Isosceles Triangle. And again, if sides are congruent, then the opposite angles are also congruent. So 2 sides are the same length, then the base angles are congruent. So there's 1 congruent mark here. I can make 1 congruent mark here. There's 1 congruent mark here, so the opposite angle is over there. And so we have 2, if we have 2 sides that are congruent, we have 2 angles that are congruent, and these are called the base angles. as we move on to the next one. This one's a little bit harder to see, but we have two congruent marks and two congruent marks. And this one shows actually two arcs. They don't have marks, but they have two consecutive arcs in the triangle. So two arcs here and two arcs here. Those are the base angles, and they're opposite the congruent side. So in this one, we have our base angles are over here. They're always opposite the congruent sides. Then we have another example, and this one doesn't have the marks, but I'm going to add it. I'll put 3 here and 3 here. So if this has 3, then I'm going to put 3 on the opposite side. So 3 on the opposite side and 3 on the opposite side. And so these are our base angles. Next, we have our last example for isosceles, and we have one congruent mark here and one congruent mark here. So the opposite side, the opposite angle from this side is right here, and the opposite angle from this side is right here. And so those are our base angles. Next one that we want to talk about is a scalene triangle. And in a scalene triangle, all sides are different lengths. So all sides are different lengths. So there's nothing that we can mark on the triangles to talk about how they're congruent to each other. So we can see from the drawing that we have a long side, a short side in the middle, but we don't have anywhere to compare them to each other. The next one we have an acute triangle, and that means all angles are less than 90 degrees. So here we 76, 57, and 47. They're all less than 90 degrees, so this is an acute triangle. It doesn't say anything about the sides, it just is referring to the angles. Next example we have is an obtuse triangle. And again, we were just talking about the angle again, and this says there's one angle that's greater than 90 degrees. So we have 44 degrees, we have 28 degrees, and now we have 108 degrees. So one of the angles is greater than 90, so this is an obtuse triangle. Then we have a right triangle, and that is one of the angles is equal to 90. And remember that right or perpendicular sign is that box in the corner. And so that's our 90-degree angle. And so in this case, we have one 90-degree angle, so this is a right triangle. And then the one that we started out with was equilateral, and then we'll finish up with equal angular, but it's the same thing. Equilateral and equal angular are the same. All sides are the same length. All angles are congruent. So if we have 3 congruent marks here, and 3 congruent marks here, and 3 congruent marks here, all the sides are congruent. So then we can mark that side with 3, we can mark, or that angle with 3, we can mark this angle with 3, and we can mark this angle with 3. So if the sides are all congruent, opposite angles are also congruent.